Hello everyone, today we are going to do exercise on taking off measurement for structural steelworks based on NRM2 and according to BS standards. After completion this you will be able to extract details from BS standards, read a drawing and calculate measurements according to NRM2. We are referring to few British standards which are required to extract technical details of structure steel members. BS 41, 2005 stands for Structural Steel Sections. In this video we are using BS 41, 2005 stand to extract technical details as well as unit weight of steel members, which is required to calculate weight of steel elements and surface area. BS 10056-1, 2017 stands for Structural Steel Equal and Unequal Angles, same as previous standard. In this video we are using BS 10056-1, 2017 stand to extract technical details, such as dimensions, height, width, thickness, and radius in various parts of steel member, as well as unit weight of steel members, which is required to calculate weight of steel elements and surface area. Steel plates are also used to construction of buildings and BS 10137-1, 1996 is used to calculate its weight. Also the standard illustrate the properties of steel plates. Properties of steel elements. In this small segment of session we are looking at specific details of steel member such as dimensions and weight. BS 41, 2005 standard. There is a way to identify each type of column as well as beams. In this exercise we are using steel column designated as 356 by 406 by 235. As per the standard dimensions of the steel member is as follows. Height is 381 mm, width is 394.8 mm, and mass per unit length is 235.1 kg per meter. Furthermore, thickness of the web is 18.4 mm. Thickness of the flange is 30.2 mm and radius is 15.2 mm. You can see this technical details by referring to page 5 of the standard. In this exercise we are using steel beam designated as 610 by 229 by 101. As per the standard dimensions of the steel member is as follows. Height is 602.6 mm, width is 227.6 mm. And mass per unit length is 101.2 kg per meter. Furthermore, thickness of the web is 10.5 mm. Thickness of the flange is 14.8 mm and radius is 12.7 mm. You can see this technical details by referring to page 2 and 3 of BS 41, 2005 standard. In this exercise we are using another steel beam designated as 610 by 229 by 140. As per the standard dimensions of the steel member is as follows. Height is 617.2 mm, width is 230.2 mm, and mass per unit length is 139.9 kg per meter. Furthermore, thickness of the web is 13.1 mm. Thickness of the flange is 22.1 mm and radius is 12.7 mm. You can see this technical details by referring to page 2 and 3 of BS 41, 2005 standard. L angles are used to make connections between different steel elements as well as connect to concrete foundations. Specific names are allocated to L angles depend on the position such as erecting cleat, angle cleat, web cleat and so on. In this exercise we are using 3 different L angles and specific technical details are extracting from BS 10056-1, 2017 standard 120 by 120 by 16 L angle is equal angle and having 120 mm of height, 120 mm of width, 16 mm of thickness and 28.3 kg per meter length. You can see this technical details by referring to page 12 and 20 of BS 10056-1, 2017 standard. 130 by 130 by 15 L angle is another equal angle used in this exercise and having 130 mm of height, 130 mm width, 15 mm thickness and 29 kg per meter length. You can see this technical details by referring to page 12 and 20 of BSN 10056-1, 2017 standard. 200 by 150 by 15 L angle is unequal angle and another type of fitting used in this exercise and having 200 mm of height, 150 mm of width, 15 mm of thickness and 39.6 kg per meter length. You can see this technical details by referring to page 25 and 26 of BSN 10056-1, 2017 standard. Steel plates are another type of fittings used to make connections between two elements. In this exercise we are using one type of steel plate to bridge the connection between steel column and reinforcement foundation. Calculation of weight of the steel plates is a way to measure as per new rules of measurement 2. BSN 10137-1, 1995 defining the density of steel plates and will be used to calculate its weight. You can clarify this by further referring to subclass 5.2 in page 4 of BSN 10137-1, 1995 standard. Next part of the section focus to study about basic arrangement of the building while studying its elements, connections, and connection details. Shown image is a graphical representation of basic arrangement of the building and it consists with 9 numbers of columns and 12 pieces of beams. Also it consists of ground floor, first floor and rooftop. Shown image is the plan view of building, and used elements are as follows. 9 numbers of 356 by 406 by 235 structural steel members used as a columns for this building. 6 pieces of 610 by 229 by 140 structural steel members used as one type of beams and other type is 610 by 229 by 101. Also the basic parameters of those steel elements are shown in the illustration. Shown image is the cross-section view of the building. Also the identification and the basic parameters of those steel elements are shown in the illustration. Shown image is the cross-section and plan view of connection between steel column and reinforced concrete foundation. Also this image is useful to identify fittings used to make the connection. The connection consists of one number of 700 mm by 700 mm by 5 mm thick base plate, and 2 numbers of L angles identified as 200 by 150 by 15. The base plate attached to reinforced concrete foundation by using holding down bolts, having a dimensions of 200 mm of length and 12 mm of diameter. Furthermore, arc welding is used to connect L angles, column and base plate. Shown image is the cross-section and plan view of connection between steel column and beam. Also this image is useful to identify fittings used to make the connection. Image represents 3 connections which are 2 numbers of connections for 610 by 229 by 101 steel beam to 356 by 406 by 235 steel column. and 1 connections for 610 by 229 by 140 steel beam to 356 by 406 by 235 steel column. L angles used to make the connections are identified as cleats. Furthermore, those cleats specifically identified based on its position, such as top cleats, erecting cleats and web cleats. Erecting cleats are support to position beam in precise place. Also, it plays a critical role when passing beams load to column. Web cleats is another type of cleat used to reinforce bond between column and beam. Web cleats are attached to web of the beam and web or flange of the column. Top cleat always positioned on top of the beam, and it maintain connection between flange of the beam and web or flange of the column. 130 by 130 by 15 L angles are used as an erecting cleat. 120 by 120 by 16 L angles were used as a web cleat and top cleats, and arc welding used to attach all cleats to steel members. Construction of steel profile deck with reinforced concrete bed is another work attached to this exercise. Steel profile deck attached to beams by using special bolts. Count of 15 numbers of special bolts per square meter will be taken as an assumption for this exercise. In real situation, you need to calculate actual amount of special bolts based on the drawings and specifications for the project. Hereafter we are moving to latter part of the session and named as taking off measurement. This process is based on guidelines of NRM2. The proposed building is having 33.6 meters long, 25.6 meters width and 15 meters overall height. Blue colored beams in the image representing 610 by 229 by 140 steel members, and green colored beams in the image representing 610 by 229 by 101 steel members. 610 by 229 by 140 steel members. By considering length of the beam, we can divide this into two, and there are 6 numbers of steel members having 15 meters long and 18 meters long. Total lengths of one layer is 99 meters. Calculation of surface area is the next step of calculation. 2 times of height plus 2 times of width minus 2 times of thickness of the web plus adjustment for corners will give you the perimeter length of steel member. After calculation of surface length, it should multiply by using cumulative length of element will give you the total surface area of the steel member, and it will help you to calculate area of surface paint or cumulative area for surface treatment. Calculation of cumulative surface area is shown in the image for further reference and further calculations. As per NRM2, weight in tons of steel members is the unit of measure. Therefore you need to calculate total weight of steel members, and to do that you need mass per unit length of the steel member, and it's based on BS 41, 2005. As per the BS standard, weight per meter length of 610 by 229 by 140 steel member is 139.9 kilograms. Thereafter you need to multiply by cumulative length of the steel member from weight per meter length. Now you can see calculated weights and surface areas of all beams and columns in relation to this building. Length of cleats always depends on where it attached. As an example, the length of angle cleat, identified as 200 by 150 by 15, is equal to width of column flange. Another example is length of web cleat. It equals to net height of web. To calculate net height of web, you need to subtract 2 times of thickness from height of the steel beam. All the L angles attached to column or beam measured under fittings to structural steel, and the unit of measurement is tons. Weight per unit length as per BSN 10056-1, 2017 standard is key to calculate weight of L angles. Calculation of its weight is illustrated in here for further reference. Calculated surface area of steel member is equal to area of surface treatment of steel member. Surface treatment may be an application of paint, or application of galvanizing coating, or any other work laid on its surface. Formula to calculate of surface area of L angle is bit different from the formula to calculate surface area of steel column or beam, but the principle is same. Formula to calculate perimeter of L angle is summation of 2 times of height and width and subtract it from 0.857 times of R root. Derivation of the formula is shown here for further references. 0.5 times of R root equals to R toe, and pi equals to 3.143. are the additional details taken into account in order to derive more simplified formula. Now you can see calculated weights and surface areas of all fittings in relation to this building. Calculation of weight of steel plate is based on density of steel and is defined in BSN 10137-1, 1996. The density of steel is 1780 kilograms per cubic meter. Weight will be calculated by multiplying volume of the steel plate and density. The calculations are shown here for further reference. The sample calculations are representing how to calculate surface area of the steel plate and shown here for further reference. Now you can see calculated weights and surface areas of all steel plates in relation to this building. Steel profile deck is a composite element amalgamate with reinforced concrete and the unit of measurement is square meter as per the NRM2. Now you can see calculated net areas of all steel profile deck in relation to this building. Nuts and bolts are very useful components to make an anchor. In this example we are dealing with two types of bolts. 15 numbers of special bolts per square meter will be utilizing to mount steel profile deck to steel beam. However, in the real situation, you need to calculate the exact amount of nuts and bolts based on drawings and specifications for the project. Holding down bolt is another kind of bolt used to mount base plate to reinforced concrete foundation and the calculations are shown here for further reference.